AutoFlight has just pulled off something that could seriously change the future of electric aviation. The company recently completed a formation flight involving 3 different aircraft at the same time, led by its massive V5000 Matrix eVTOL. This wasn't just a simple demo flight either. The mission tested communication between aircraft, coordinated route planning, synchronized flight control, and overall safety systems across 2 completely different aircraft classes, flying together in real time. While most eVTOL companies are focused on small urban air taxis designed for short city trips, AutoFlight is taking a much larger approach. The V5000 Matrix is enormous compared to nearly every other aircraft in the industry. It has a wingspan of 20 meters, stretches more than 17 meters long, and weighs up to 5,700 kilograms at takeoff. Right now, it's considered the largest publicly known full-scale crewed eVTOL currently in development. That size becomes even more impressive when compared with other well-known aircraft in the space. Aircraft like the Lilium Jet, Joby's S-4, Beta's Alia, and Archer's Midnight are all significantly smaller in both weight and overall footprint. The Matrix is operating in a category that very few companies are even attempting to reach. What makes this aircraft especially interesting is that it's being developed in 2 different versions. The passenger model is fully electric and designed to carry up to 10 passengers in a business-class style cabin. There's also a VIP layout for 6 passengers that includes luxury-style features like climate control, ambient lighting, large windows, and even lavatories. AutoFlight says the experience is meant to feel closer to a private jet than a typical air taxi. The electric version can travel around 250 kilometers on a single charge. Earlier this year, the passenger version successfully completed a full transition flight in China. That means it managed vertical takeoff, shifted into fixed-wing forward flight, and then returned to vertical landing without issues. That transition is one of the hardest technical challenges for eVTOL aircraft, and many competitors are still working toward it. The cargo version takes things even further. Known as the V5000 CGH, this model uses a hybrid electric propulsion system instead of running purely on batteries. That gives it a huge boost in range and performance. It can carry up to 1,500 kilograms of cargo inside a 14 cubic meter storage compartment, large enough for standard aviation cargo containers. The aircraft can travel up to 1,500 kilometers at speeds reaching 280 kilometers per hour, putting it firmly into regional logistics territory instead of short-range urban flights. AutoFlight also confirmed that the cargo version has officially entered the airworthiness certification process. That's an important milestone because it means the aircraft is moving beyond experimental testing and into the path toward real-world regulatory approval. The Matrix uses AutoFlight's lift and cruise design, which separates vertical lift from forward cruise flight. 20 lift motors work together during takeoff and landing, while the wings handle lift during normal flight. According to the company, the system can continue operating safely even if 2 motors fail at the same time. That level of redundancy is critical for an aircraft carrying passengers or valuable cargo. What makes this project even more futuristic is the infrastructure AutoFlight is planning around it. The company has already shown concepts for floating solar-powered airports that could sit on rivers or coastal areas. Pairing those platforms with a large aircraft like the Matrix could create entirely new transportation networks for cargo delivery, emergency response, and operations in regions where traditional airport infrastructure doesn't exist. The V5000 Matrix feels less like a city air taxi and more like the beginning of an entirely new category of electric aircraft. AutoFlight isn't just trying to move people across downtown traffic. The company appears to be aiming for regional transport, heavy cargo operations, and large-scale aviation networks that could stretch far beyond what most people currently associate with eVTOL technology.